This is the third section in the integration chapter. This is using trig identities. Now, using trig identities can be a bit tricky because sometimes you don't always spot what the trig identity is or what substitution to make, but there are a few suggestions that I can give you that are useful ones to look for. So for example, if you see something like sine x cos x, that's half of the double angle for sine, so that's a useful one to use. So you'd be able to integrate the half sine 2x, but you wouldn't necessarily be able to integrate without difficulty the sine x cos x. So normally when you see like a product of trig, you want to use a trig identity. When you see some trig in like squared, that's the same as cos squared, or something like this, sine squared x. We can't use the reverse chain rule because this inside isn't linear, is it? Remember, the reverse chain rule only works if the inside is linear, so you can't use the reverse chain rule. So we'd use an identity to change those, and we have the double angle for cos, so we have cos 2x is equal to 2 cos squared x minus 1, or cos 2x, a different form, is 1 minus 2 sine squared x. So you've got the sine squared and cos squared here, so this could be rearranged to deal with those. Yeah, so that's useful. Also, as well, don't forget your Pythagorean identity. So 1 plus tan squared is sec squared. So if you've got a tan squared, you might want to change it to sec squared because sec squared's in the list. 1 plus cot squared is cosec squared. So again, that may be useful as well. And sometimes it might be just simplifying some trig that you've got to make it into something that's in the list. So I don't know, for example, you might have something that becomes sectan. Yeah, so let's try and think of something. Sectan is in the list, but you might have something like 1 over cos x times sine x over cos x, yeah, which may have been something like sine x over cos squared x. So let's say the question said integrate this. Well, that's the same as this, that's the same as this, and this is what's in the formula book. So sometimes it's just a case of writing it in a different form, but there's some things there that you might find useful. So this first one here, tan squared, always look for the trig in the table. It's not in the table, but there's a big hint at the top, which is because sec squared is 1 plus tan squared, that means, well, tan squared x you can write as sec squared x minus 1. So we'll integrate sec squared x minus 1 dx. Sec squared is here, so that just becomes tan x. Tan x minus 1 minus x plus c. Okay, here we had one similar to this before. We had to show it was equal to log 12 or something. Show that that integral gives you that. So the first thing that we need to do is we can't integrate sine squared easily, can't use the reverse chain rule, but we can use this identity up here, and if I rearrange it to make sine squared x the subject, I will have 2 sine squared x is equivalent to 1 minus cos 2x if I just swap the sides of those two things. If I divide both sides by 2, I'll have sine squared x is a half minus a half cos 2x. Right, so that means this integral between pi over 12 and pi over 8, remember it's always going to be in radians when we're dealing with differentiation and integration with trig. The sine squared x I can replace with half minus half cos 2x dx. Now notice that half is a factor of both of these, so if I want I could do this, put half over here, don't need to, could leave it as it is, and then make this 1 minus cos 2x. You might find that a little bit easier to do. So what will happen is the 1 will become x, and the cos 2x, now we need to use the reverse chain rule to do this. So you integrate the outside, so cos becomes sine, the inside of the bracket doesn't change, that's the 2x, and you divide by the inside differentiate, so we divide by 2. So what I'm going to do is move that minus across, so I can put my divide 2 here as a half and put my minus there, and I have my limits of pi over 8 and pi over 12. So now what I'm going to do is work that out. So it's going to be a half of all of this, pi over 8, so I just substitute it in, minus half sine pi over 8 times 2, 2x. Let's put some more brackets in here, like that, minus pi over 12 minus a half sine pi over 12 times by 2, and then once I work that, all of that needs to be divided by this, or times by a half here. So let's work this out. Now you can't just put this all in on a calculator because you'll just get a decimal answer, so you do need to work it out step by step. I'll try and get it all in here. So if I work out the bits here where I've got the sine, then I will have half, and then in the first bracket pi over 8 minus root 2 over 4 minus, I'm splitting the brackets up, well they're split up anyway, and then pi over 12, and then minus a quarter. If I expand those brackets out and then put them all over the same denominator, which is going to be 48, I'd get 3 pi over 48. I missed out a step because I just want to make sure I've got space. 6 root 2 over 48 minus 6 root 2 over 48 minus 2 pi over 48 minus 6 over 48. So all I've done there is I've worked out what this is by expanding the brackets. They were different terms like over 16 over 8 over 24, so I put them all over the same denominator. Now once I've done that, I can put them together. So I've got 3 pi over 48 minus pi over 48 just leaves pi over 48. Now they've got a plus sign, so I'm going to put a plus sign in here. Now if I put a plus sign, that does mean that's going to swap what I have up here, yeah, because actually I've got a negative 6 root 2 over 48. I might just write that down. So I've got over 48 So because I've got a minusing a negative, then I will have, actually that should be a plus, that's why, because I've got negative, negative, that will make sense, yeah. So plus, and then I will have 6 minus 6 root 2. Okay, this can be cancelled down. Divide everything by 6, so you get 1, 1, and 8. So you get what's required here. So pi over 8 plus 1 minus root 2 all over 8 QET. So we've proved it as required. Right, another trig identity here. This, we need to be thinking about the double angle for sine. So if I write this down, sine 2x is 2 sine x cos x. So sine 6x is always double, is going to be 2 sine 3x cos 3x, which means if I divide both sides by 2, this integral becomes half, what's written down there is actually half of sine 6x, which we can integrate using reverse chain rule because the inside is linear. There it is, 6x. So oh, and another thing we can do, let's do that actually, is put the half out the way. I always like putting constants over the other side out of the way. It just makes things a little bit easier when you get those numbers out of the way. Then you can just concentrate on the integration. So it's going to be half of what I get when I integrate sine 6x. So you integrate the outside, so sine becomes negative cos. Inside of the bracket doesn't change. You divide by the inside differentiated, which means dividing by 6. So let's cheat and put 6 there and a minus. Then we can expand it all out. I know it's going to have plus c at the end. So this is going to be negative 1/12 cos 6x plus c. For b over here, not anything that we can substitute in, so we're going to start by expanding the brackets. So if we do that, we'll get sec squared x plus 2 lots of sec x tan x plus tan squared x. Right, now let's have a look at our list. Sec squared x, that's fine, I can integrate that. Sec tan, that's fine, I can integrate that, that's in the list. The tan squared, well, I can use 1 plus tan squared and change that into sec squared. Yeah, and in fact if I change this to sec squared, I can then put it, maybe put it onto that. Anyway, let's see how we go. So equals, let's just do the substitution first, plus 2 sec x tan x, and then it's going to be sec squared minus 1, so plus sec squared x minus 1 dx. So that will become 2 sec squared x plus 2 sec x tan x minus 1. Now what I'm going to do, I'm going to do this. I'm going to take a 2 over, so you'll see this. So if I take the 2 over, I'll have sec squared x plus sec tan x minus a half. Yeah, see what I've done there? Dx. Right, now let's integrate that. Let's separate this out so we know what is what. Here we go. So that will become 2 lots of, so sec squared becomes tan x. Sec tan becomes sec x. half becomes half x plus c, and then what we do is multiply it all out by 2. So 2 tan x plus 2 sec x minus x plus c. Right, you should now be able to do exercise 11c, and this is just on page 300. Now remember, try and memorise these ones here. Yeah, because they won't be in the formula book, and if you can memorise them, it'll be better for you. Otherwise you won't have them for the exam.